Okay, good morning, everyone. We are here to share to you our project that we've been putting together for the Augmenting Human Dexterity class, particularly focusing on a project proposal that we're excited might really be able to help the space with people with Parkinson's disease.
Right, so a little bit about Parkinson's disease. It's an incurable neurodegenerative disorder that affects the neurons in the brain that produce dopamine. So it's a progressive disease. It develops slowly over the years. And it can include the following motor symptoms. So you can experience tremors in your hands, bradykinesia, limb rigidity, and gait imbalance issues. But there's also these non-motor symptoms, which can include depression, sleep disorders, cognitive impairments, and gastrointestinal issues. So for current treatments, the gold standard is levodopa, which is a medication that's a dopamine replacement. However, it is known that it does have side effects, including dyskinesias, which develop over the years, and it's an abnormal involuntary movement. Another commonly known treatment is deep brain stimulation, which involves electrodes being inserted into the patient's brain and an IPG or impulse generator battery inserted into the patient's chest or abdomen. So then from there, the patient is then able to control sending electrical impulses to their own brain whenever they experience tremors or stiffness. So there's a bunch of current assistive devices that Parkinson's patients can use. Um, they can use a voice-controlled cursor, which replaces their mouse because tremors in the hands can cause a lot of shakiness when trying to move a mouse around. They can use adaptive eating utensils so that their food doesn't fall out of their utensil as they're trying to eat. And again, kind of along that same line, writing utensils so that their handwriting isn't as shaky. They can use walkers and walking aids or organizing tools, so because Parkinson's can also affect memory a little bit. And then smartwatches, which can also help them with reminders or tracking health. So we decided to interview a Parkinson's patient to get some more information before designing our study. And we found that this patient was very interested in only non-invasive solutions. They weren't interested in deep brain stimulation or anything that was invasive. We also found out that the tremors that the patient experienced also really affected their ability to read the newspaper, fill out crosswords, and type family emails, which were all things that they enjoyed before they were diagnosed. This patient also had to record blood pressure 3 times daily in order to show that information to their doctor, and also had a lot of difficulty getting appointments with a neurologist. They also shared that they enjoyed using a voice command system called Alexa to check the news, weather, and play Jeopardy. So our hypothesis is that combining these existing assistive technologies into one system can provide Parkinson's patients with a more usable toolkit. It'll increase their confidence and their ability to live independently, and we also predict that they'll receive it pretty well and prefer it over the separate assistive systems.
Yeah, so just to reiterate that a little bit, there, like Moriah said, there's tons of these assistive systems in the space that exist, but there's no unified system. So they either have to have all these different bits of technology and try to get them to work. There's been a lot of great studies on these isolated pieces of technology, but never one on the unified system. And so we were really interested in seeing how that could benefit. So what we did is we designed the totally novel voice-activated home automation solution. We named it Alex. Don't know where we came up with that. And we want to see how we can test its efficacy. So what we're proposing is a subjective study based on a study that has already been done many times and existing with people with Parkinson's disease. The reason we're choosing a subjective study is because we want to test things like their acceptability, how much they like using the system over the isolated systems, and that's inherently subjective. So what's been done in the space before is people use, for example, a journal where they document their usage and see if they like it, and they just talk about different metrics that they can use it with, like the time it takes to do tasks and things like that. But also we need to realize that this is a protected population. So we need to really ensure that the study design was conforming to these city regulations on human test subjects. So we are confident that by performing the study, we're really helping this population of people with Parkinson's disease. And as a result, we're also making sure that anyone coming into the study that we're proposing is well aware of what's happening in the study, where the results will be, and the fact that they won't actually be able to keep any of the hardware that we're providing them ahead of time. So this is kind of our high-level ideation phase, and I'm going to walk you through it here. So at the top, circled by this ring, one of the things we wanted to incorporate into our Alex system is the fun and social category. So, you know, from our interviewee, we found they love to play crossword, they like doing Jeopardy, they also find it really important to talk with their family and do these things. And that can be really difficult if you're trying to do these things on individual apps on a phone. And for example, our interviewee had pretty intense tremors, and it was actually very difficult. And it turns out he had his wife doing almost all of that for him. So another category is physical help. Now, granted, this is for people who are very much more progressed in the disease as far as physical ailments go, like Moriah mentioned, those tremors, and it can make even taking a shower and opening doors very difficult. Another aspect is health and security. Health and security is a very big concern because walking around, doing a round of your house at night, making sure all the doors are locked, arming your alarm, pressing those small buttons, these things we kind of take for granted can be very difficult for this population. Another thing that we wanted to hit on was the health. Getting in contact with a neurologist is not as easy as you might think. The actual contact with the doctor is quite infrequent, and that's why our interviewee had to measure their blood pressure 3 times a day and make sure to convey that information at some point. And so we wanted our system to be able to incorporate some telemedicine approaches that can ease and really, you know, streamline the way that these patients and people are communicating with their physicians and neurologists. And lastly, of course, we needed to make a system that didn't lose any functionality over existing systems. So we incorporated the standard smart home control of appliances, TVs, and things like that. So again, just to reiterate, our study prototype is pretty large. And so in order to make it a realistic first line proposal for a study, we descoped it greatly to focus only on that physical aspect. Again, that's the sinks, the doors, the locks, things like that. And so what we're proposing is that we want to install these microphones, door actuators, and sink valves to operate the faucets and the showers, things like that. And our study is going to look something like this. We want to set up a mock home space in a lab that we can control. So we don't actually have to install all of this hardware in every single test subject's home. So we set up this lab space in a quote unquote home space. And for $5,000, we can basically put in all the sink valves, all the actuators, all the microphones, and have these people come in at a regular basis. So 28 participants over 8 weeks. We're going to have them keep journals, again, looking at those subjective metrics for preference, acceptability, feelings of independence, and we are going to track that compared to a control of another home space that we have not augmented with these things. And another quantitative metric that we're going to look at is the time to perform the set of tasks. So we're combining a qualitative and quantitative nature of a study. Just to get low level for a second here, I like the nitty-gritty details. Don't pay too much attention to this, but it's basically just all our microphones, our thermistors, and our solenoid valves to control the sink and whatnot. Just wanted to share that real quick. So next steps would be to, provided we run the study and we get good results, we can see, our proof of concept is valid. We would love to expand our Alex system to include all the other categories that we previously mentioned. And we also want to install the system into the homes of the participants rather than having our home lab set up. We would love to also run an extended study of this Alex system versus the other assistive technologies on the market as well. And we would do this using the same metrics. So provided, again, this is if our proof of concept goes well, we would sort of expand out, go for more funding on a second round of approach. Don't forget to like, subscribe, rate 5 stars. Thanks for watching our presentation. Hope you loved it. All right, signing off.